Hello, hello, and welcome everyone to another exciting Wednesday night TeleTube broadcast. Welcome to York Observatory YouTube TeleTube, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. This is Dr. Elena Hyde, and I am absolutely thrilled to bring you a broadcast tonight all about the countdown to Mars, excuse me, presented by our fabulous students, Sana, Gagan, Noah, and featuring a inaugural broadcast by Obata. So everyone, congratulations, and I cannot wait to hear what our wonderful students have planned to tell us about Mars tonight. All right, take it away, crew.
Thank you. Good evening, everyone. I'm Sana, and I'm here today with Gagan, Noah, and Obata from York University's Alan I. Carswell Observatory. In light of the 3 missions to Mars that have launched these past couple weeks, tonight's episode will be all about Mars exploration. We hope you enjoy the presentation. To start off, let's talk about some of the basics of the red planet. Mars is the 4th planet from the Sun and formed about 4.6 billion years ago, along with the rest of our solar system. It's about half the size of Earth, has a mass of 1/10 that of the Earth's, and it also has 2 small moons, Phobos and Deimos, that may be asteroids captured by Mars's gravity. How about its orbit and rotation? One day is defined to be the time it takes a planet to complete a full rotation on its axis. For the Earth, this is 23.9 hours, and for Mars, this is 24.6 hours. Scientists have named a Martian day a sol. Finally, 1 year on Mars, which is the time it takes the planet to complete a revolution around the Sun, is 687 days, or 669.6 sols. Mars orbits the Sun at an average distance of 228 million kilometers. However, like all planets in our solar system, its orbit is not perfectly spherical, but it's shaped more like an oval, so its distance from the Sun varies over the course of its orbit. This is called an elliptical orbit, and it has some interesting consequences for Martian weather. To learn about weather on Mars, we first need to take a look at its atmosphere. The Martian atmosphere is composed largely of carbon dioxide, with some other gases such as nitrogen and argon. While the atmosphere is very thin, exerting a pressure of only 1% that of the Earth's, its atmosphere allows for weather, including clouds and snow that consist mainly of carbon dioxide. Just like Earth, Mars has 4 seasons, but seasons on Mars are much longer and of variable length, even varying across different hemispheres. This is because Mars's orbit is more eccentric, so more oval-shaped than the Earth's, and because its year is longer. A diagram of the Martian orbit and its seasons is shown on the left of the screen. Temperatures on Mars range from minus 140 degrees Celsius in the winter to 30 degrees Celsius in the summer, with the seasons in its southern hemisphere being much harsher than those in the northern hemisphere. One fascinating weather phenomenon on Mars is its dust storms. Mars has many smaller dust storms, like the one shown on the bottom right of the screen, that sometimes grow into massive storms that engulf the entire planet and last for months. These dust storms begin when wind picks up the powder-like dust from the surface and grow when hot and cold air interact. Dust storms are more prominent when Mars is moving from winter to spring, with spring serving as the dust season. Speaking of Martian dust, why is Mars red? The red planet gets its name because of iron in the rocks and dust at its surface rusting and turning red. Moving underneath the surface of Mars lies the crust, which consists mainly of volcanic basalt rock. Moving even further below that, the Martian interior consists of a solid core of iron, nickel, and sulfur, and then a mantle of silicon, oxygen, iron, and magnesium above the core, as shown on the slide. Since its core is solid, Mars does not have a global magnetic field, instead having some localized magnetic fields. Coming back to the surface, Mars is home to both the largest volcano and canyon in the solar system. The largest volcano is Olympus Mons, and is 3 times as high as Mount Everest, at 624 kilometers, and is also the size of Arizona. This and other large volcanoes on Mars formed long ago when Mars was hot enough to have a liquid core, and lava flowed to the surface and piled up in one spot, forming volcanoes. The largest canyon, the Valles Marineris, is about 10 times the size of the Grand Canyon, stretching about 4,800 kilometers across and shown on the slide. The Valles Marineris is essentially a large crack in the Martian crust that formed many years ago when the planet was cooling. Some other features on the surface of Mars are craters, valleys, and polar ice caps, which all provide evidence of water on Mars. Billions of years ago, it appears that Mars was very Earth-like. Its atmosphere was thicker, allowing it to better retain heat, and was thus warm enough to support liquid water. The weather on ancient Mars existed in lake beds and flowed through networks of valleys that are still present on Mars today. There is even evidence to suggest that Mars had so much water that it flooded billions of years ago. The image on the top right shows some of these valleys. Since Mars is so small, much of its water and atmosphere dissipated into space over time, turning it into the cold world that it is today. However, there is still quite a bit of water on Mars. Most of the water on Mars is in the form of water ice under the surface, in craters or in polar ice caps. The image on the left shows some water ice in a crater, and the bottom right image shows how the size of the polar ice caps on Mars varies over different seasons. While the polar ice caps are mostly water, they also contain some frozen carbon dioxide. In addition to ice, flowing liquid water exists both on and underneath the Martian surface today. The temperatures and pressures on the surface of Mars make it difficult for liquid water to exist there, so the current water is salty, which lowers its freezing temperature. What does all this say about life on Mars? In short, life on Mars would likely be microbial and would probably not exist currently, but rather in the past. This is mainly because there is not much water left on Mars, which is a requirement for life to begin and thrive, and also because Mars experiences high levels of radiation at its surface, which is harmful to life. As mentioned, Mars used to be much more Earth-like, with a warmer climate and much more water, making the chances of life much higher than today. Because of this, scientists are actively searching for evidence of past life on Mars with various missions, both past and present. Next, Noah will tell you about the history of Mars exploration.
Thank you, Sana. So Mars is known for its potential to be the next Earth, our next home. To get us there, though, Mars requires a lot of analysis and exploration to educate and prepare us. This past month, exploration of Mars has been at the forefront of society. So here, I will describe the past, present, and future of humanity's direct and indirect presence on Mars. Mars has always piqued the curiosity of humankind. But why is it one of the main features of our exploration endeavors? I'll go further into the exact purposes of specific missions in the next few minutes, but right now, I'd like to discuss the main reasons for Mars exploration in the first place. Why are so many countries, companies, and agencies working on getting to Mars? For starters, Mars is the closest planet to us, and thus the easiest to explore. It's also a terrestrial planet, with a surface on which we can land. Not only that, but it has the ability to teach us more about our own planet through geological and evolutionary analyses, as the InSight mission does, which you can see in the image on the right. The most famous reason, though, is no doubt that Mars has the potential to sustain life, the potential to host water beneath the surface, and thus exploration helps us to understand more thoroughly the implications of human space travel to and colonization of Mars in the future. Through exploration, we can work to learn about the planet itself, about resources available to us, and about dangers we may face, among other critical pieces of information. Current exploration is the key to informing us about the planet next door, and also provides the stepping stone for the future of research and travel. Now, before I actually discuss the missions that have occurred and are occurring, we must first learn about a couple of the challenges and barriers that limit our ability to explore Mars. In fact, almost half of the attempted Mars missions have been unsuccessful. Regardless, overcoming these issues enabled the present successes to occur. First and foremost, NASA's Perseverance rover and Ingenuity helicopter launched last month, as did China's Tianwen-1 and the United Arab Emirates' Hope probe, while the European Space Agency and Roscosmos were supposed to launch their ExoMars Rosalind Franklin rover a few weeks ago as well. Why were all of them scheduled for launch dates within the short span of a month, let alone 2 weeks, you might be wondering? Well, launches to Mars can only occur every 26 months, when Earth and Mars align and the two planets are closest together, as seen on the left of the slide. This enables the least amount of time, fuel, energy, and money to be utilized on these spacecraft. Due to this time limitation, regardless of the COVID-19 pandemic, most space agencies made the decision to persevere, Fitting name for the rover, isn't it? And maintain the launch within this year's window, such as to avoid having to store the robotics for another 2 years. Another major barrier to Mars exploration is no doubt the dust storms that occur, as previously mentioned by Sana. When storms like this occur, the sun is completely obscured, as depicted on the right, preventing the solar-powered Mars devices from functioning, be it by lacking the ability to charge their batteries, maintain warmth, or even correspond with Earth. Some rovers are forced to enter what is known as low-power fault mode, where nearly all systems are put to sleep. This can be a major setback in exploration completed by missions, let alone uncrewed missions. So now let's go back in time to where Mars exploration started, such that we can see how far it has come. The world began sending missions to Mars as far back as 1960, but it wasn't until 1964 that a mission actually accomplished its goal. NASA's Mariner 4 mission successfully reached planet Mars as a flyby that year. It managed to take a total of 24 images of the red planet, one of which can be seen in the middle on the right-hand side. The subsequent Mariner missions even managed to examine both Mars's surface and Mars's atmosphere with the use of remote sensors. Around the same time, Russia completed its first successful Mars mission with the Mars 3 orbiter and lander. While Russia's orbiter transmitted 8 months of data from above Mars, its lander companion became the first exploration device to land on Mars. This mission was followed up by 2 others before moving on. NASA's next missions consisted of the Viking missions, bringing again both orbiters and landers to the surface of Mars. From Viking 1 and 2 in 1975 and 76 came the start of a new era, the experimentation era, where the soil and atmosphere were sampled and analyzed. You can see one of Viking 1's images on the bottom right. NASA followed this up with further successes of the Mars Global Surveyor, Pathfinder, Odyssey, Reconnaissance Orbiter, and Phoenix Mars Lander on the top right, all of which, joined by the European Space Agency's Mars Express Orbiter, not only provided new standards of the length of operational time on Mars, but provided an enormous collection of both high-resolution photos and detail, on top of the data that revolutionized how humanity understood Mars. Mars Pathfinder was actually able to gather information of Ares Vallis, a floodplain that had previously existed, from both its lander and our first ever Mars rover, Sojourner, illustrated in the animation top middle on the page. Numerous other missions occurred after the historic ones mentioned from the United States, Russia, the countries of the European Space Agency, India, and China, studying Mars's habitability, the atmosphere, mineralogy, and surface features. Next comes some of the most popular aspects of Mars exploration to date, the start of the rover missions. In 2003, the United States launched Spirit on the left and Opportunity on the right, both of which focused on the climate, as well as the quest for signs of water existence. Once, when one of Spirit's wheels broke, by scraping the soil away, dust containing silica even indicated the presence of this desired liquid from the high concentration. The rover captured these soil tracks in the central image. A fun fact about both of these rovers is that they lasted way beyond their expected 90-day lifespans, Spirit stopping in 2011 and Opportunity only 2 years ago in 2018. Through these long journeys, both Spirit and Opportunity transmitted their data to many of the probes and orbiters I mentioned previously. Spirit's last legs began when it became stuck in the sand, after which the cold likely initiated its inability to function. Opportunity's demise, on the other hand, was actually due to the planet-wide dust storm that blocked the sun entirely from the rover's solar panels, one of the major exploration barriers I mentioned earlier. There is no doubt that the world has put out a number of missions, or over 45 to be exact, and many of them have been successful. But we most definitely did not stop there. As I mentioned, this month has seen huge successes in launching to Mars. Numerous missions are in progress today, and the Curiosity rover, featured on the far left, is no exception. One of the most popular exploration objects, Curiosity has had enormous success since its launch in 2011. Its goal was to determine whether microbial life could have existed on Mars, and it has, in fact, acknowledged the presence of habitable regions. It continues traversing the rocky surface to this day, analyzing the air, rocks, and soil of Mars's Gale crater for further information on this topic. As I said, both the United Arab Emirates' HOPE probe and China's Tianwen-1, which translates to Questions to Heaven, launched last month with big plans for the Red Planet. While the former will orbit Mars for 1 Mars year, collecting new information on the entire atmosphere and potential life, The latter sent up an orbiter, a lander, and a probe for observations, attempting a new method of exploration with all three technologies launching and arriving at once, then communicating between themselves. Tianwen-1 intends to study the atmosphere, climate, soil, ice deposits, and surface composition of Mars, as well as the electromagnetic and gravitational fields. You can see both the UAE and China's accomplishments on the right. The third and final launch this month occurred when NASA launched its Perseverance rover and Ingenuity helicopter only last week on July 30th. These two devices in the center are critical to finding out more about Mars and Mars's potential. Among its many mission goals, Perseverance hopes to determine whether or not life has ever existed on this planet, learn more about Mars's evolution through geology, and conduct various activities and research for potential future human exploration. Many of these preparative endeavors included experimenting with the use of Martian resources for fuel and studying the atmosphere to derive the best ways to protect and maintain our own life. Obata will explain more about Ingenuity to you in the next section. According to NASA, and I quote, this science goal relates to the national space policy for sending humans to Mars in the 2030s. Similar to the history of the exploration of Earth's moon, robotic missions to Mars provide a crucial understanding of the environment and test innovative technologies for future human exploration. Human exploration to Mars is the ultimate goal for agencies and private corporations around the world. Elon Musk actually announced in 2017 that SpaceX is preparing to land crewed ships on the planet by 2024. Well, there is no doubt that the present is exciting and the future is bright for Mars exploration. I'm excited to see what's in store.
Thank you, Noah. Now moving on, I'll be talking about some of the technologies used in various missions and upcoming technological advancements that can improve interplanetary travel and possible settlements on Mars. Some of the older Martian rovers, Curiosity, Spirit, and Opportunity, all have the various scientific instruments used to analyze the surface of Mars and learn about its geology. They all have a large variation of cameras, spectrometers, radiation detectors, and many of them essentially have their own mini weather station for atmospheric studies. When combined, the data these sensors send to scientists is astounding. It allows for them to learn so much about Mars without ever stepping foot there. The Perseverance rover that launched just last week has greatly improved sensors and scientific instruments that are more fine-tuned for detecting ancient microbial life that may have existed many years ago. This may be possibly the first official attempt to search for life on another planet. It also has an oxygen generation device called MOXIE, used to demonstrate the ability of converting the abundant CO2 into breathable O2 for future manned missions. The Curiosity rover is also turning 8 years old today. Happy birthday, Curiosity. Perseverance, however, did not launch on its own. It brought a friend named Ingenuity. The Ingenuity helicopter will work closely with the Perseverance rover to gather very important data about the surroundings for close proximity terrain mapping. It will help Perseverance plan its route safely and accordingly. The helicopter is equipped with 2 counter-rotary blades revolving at about 2400 RPM. Although the craft only weighs 1.8 kilograms, the extremely high-powered blades are necessary to compensate for the lack of atmosphere on Mars. The scientists at the Jet Propulsion Laboratory have really thought of everything and have created an ingenious design. The aircraft will fly on short intervals of around 90 seconds due to its small battery life, which is no small feat compared to the 12-second flight of the Wright brothers. Ingenuity will be the first example of flight on another planet. Of course, none of the rovers or helicopters on Mars can function without prior sufficient data of the Martian terrain. This is where LiDAR detectors come in handy. LiDAR is an abbreviation for light detection and ranging. It is a sensor that uses lasers to measure distances, and it's able to produce 3D images of surfaces and allow for in-depth understanding of the terrain. This very technology was implemented on the Mars Phoenix lander of 2008 by a joint collaboration between NASA and research universities, including York University. Professor Carswell, founder of the Alan I. Carswell Observatory, this very place that we are broadcasting from right now, helped to advance this technology. It works by sending laser pulses at an object which you would like to measure the distance of, and measures the time it takes for the signal to return. This is almost identical to radar speed guns, which measure the change in distance to output a value on the velocity of an object. Many of the satellites that orbit Mars and the current rovers on the surface all use LiDAR to gather topographical data to construct 3D images of the surface of Mars and help advance the understanding of the terrain of the planet. Now, transitioning into possible future technologies, we will talk a bit about ion propulsion and how it can optimize interplanetary travel. Ion propulsion is different from your ordinary chemical-powered rockets. Spacecrafts equipped with an ion thruster produce thrust by accelerating charged ions at a fraction of the speed of light. The downside, however, is that currently, using ion propulsion generates an extremely low thrust, which is not sufficient to travel to Mars, and certainly unsuitable for launches off the surface. This method of propulsion, however, shows very promising signs, as it is currently being developed to accelerate spacecrafts in deep space missions. The way it works is by firing electrons at a neutral gas propellant, typically xenon. The electrons then break the propellant into charged particles, which are directed out the nozzle by using magnets and by applying a high-powered electric field. The clear advantage of ion thrusters compared to chemical propulsion is a small fuel load. Since the thruster requires subatomic particles and light gases for electrical acceleration, the weight of the fuel is minuscule. Now, once humans arrive on Mars, simulating an Earth-like atmosphere on another planet isn't very easy. Any humans living on Mars must have the proper technology to overcome environmental hardships and challenges. The biggest challenge we face is the dangerous weather and atmosphere and the high levels of radiation on Mars. As Sana already mentioned, Mars' atmosphere is 1% that of Earth's and is composed mainly of carbon dioxide. There are extreme winds, sandstorms, and radiation levels that are too high for any ordinary person. There are many propositions for how a settlement can be built while protecting humans from the harsh environment. One possibility is for the settlement to be built partially underground, or to have some parts buried in the Martian sand. This is a very optimal solution, as having a structure a few feet under the surface will be sure to protect against radiation and extreme weathers. The settlement must be fully sustainable and able to produce its own energy and food. The soil of Mars must be reconditioned to allow for plant growth, and a method for energy production must be developed. We still, however, are very far from this goal, but current space programs and private space companies are all pushing toward this common goal. Next up, Gagan will be talking in detail about more of the challenges humans may face on Mars.
Thank you, Abada. While human presence in space was established almost 60 years ago with Yuri Gagarin's pioneering orbital flight, the furthest humans have ever been in space is around the moon. Since then, space agencies have had their sights set on Mars exploration, and there has been a lot of talk about potential future manned missions. However, there are some major obstacles that we face in order to set foot on the red planet. One of the first things we have to consider when we think about manned missions to Mars is the journey getting there. Mars is always considerably farther away than the Moon, even when Earth and Mars are at their closest in their orbits as a close approach. Close approaches occur every 26 months, and the range and distance is about 55 million kilometers to 100 million kilometers. In comparison, the distance to the Moon is only about 384,000 kilometers and remains relatively constant. Since there are over 2 years between each close approach, launch windows to Mars only come around every 2 years, and if a launch opportunity is missed, the mission has to wait 2 years for the next chance to launch. This past month, as Noah talked about earlier, 3 different countries took advantage of a close approach launch window, and all 3 missions are successfully en route to Mars, one of these being the NASA Mars Perseverance rover. Greater distance means longer missions, but it's a little more complicated than that, since Mars and Earth are on different orbits. If a mission launches from Earth while Mars is at its close approach, it will take a few months to get there. However, the return trip will be much longer because the distance between Earth and Mars will have increased significantly in the time since launch. Manned missions also require food, water, and resources for the entire duration of the mission, plus extra in case of an emergency. Researchers have been considering options to make water and fuel from materials found on Mars and in the Martian habitat, which would be sustainable for continued settlement, but more difficult for shorter missions. Storage for resources, combined with the added space needed on board for a long interplanetary mission, means a larger and more powerful vehicle would be required for that mission. Another important part of a potential mission to Mars is the arrival there. In the past, the most likely way to get humans to the surface of Mars would be by having a craft launch and enter orbit around the planet, from which a lander will be deployed which delivers astronauts to the surface safely. Recently, however, SpaceX's Falcon vehicles have shown they can land and relaunch multiple times, which may be ideal for a future Mars mission. In any case, humans are a lot more delicate than some of the machinery and equipment that we've, for lack of a better word, tossed onto Mars in the past, and the landing has to be just right to make sure nobody is hurt in the process. Right now, when astronauts return to Earth from the ISS, like they did on Sunday afternoon, they splash down in a capsule like the one pictured on the left of the slide, at a predetermined location in the ocean, and they are retrieved by a recovery crew. Without the possibility of this kind of recovery on Mars, astronauts must have a safe soft landing and a way to disembark without assistance. Similar conditions are necessary for leaving Mars. The crew must be able to independently board and launch their vehicle from the surface of Mars to return to Earth. As with any space mission, emergencies have to be prepared for ahead of time. The safety of the crew is of paramount importance, and many variables such as machinery function and weather conditions can impact the mission. The vehicle responsible for Mars departure must be available for launch at all times throughout the mission in case of an emergency, and the astronauts will have to be well trained in order to deal with any potential challenges the mission may encounter. To make matters even more difficult, the distance between Earth and Mars means that there will be a communication delay between mission control on Earth and the astronauts. Communication can only be as fast as the speed of light, and the minimum delay in communication is approximately 3 minutes, and that's barring any potential tech issues. The crew must be able to adapt to their situation and make the best out of their mission independently. One of my favorite science fiction books, The Martian by Andy Weir, outlines an example of a mission to Mars where almost everything goes wrong, and it highlights the importance of astronauts being able to find their footing when a mission's details become uncertain. Once astronauts are on the surface of Mars, another big question is where they'll live when they're there. It wouldn't make sense for us to invest billions of dollars into a mission where astronauts would only be there for hours or a couple of days, so a longer mission is more likely. That being said, we can't expect the crew to live in a small lander vehicle for a month, and they'll need somewhere to do research as well as live and have some downtime. As Senna mentioned earlier, the conditions on the surface are very different than on Earth. The atmosphere on Mars is only 1% as dense as Earth's, and the temperatures fluctuate rapidly with extremely cold nights. However, there are a few regions with more seasonally Earth-like climates that may be candidates for landing sites in the future, such as the Hellas Planitia. The surface of Mars is also exposed to high levels of solar radiation and unpredictable weather, like the dust storms pictured in the middle. No humans would be able to survive without a spacesuit or Earth-like environment on the surface of Mars, and for a longer mission, a temporary living facility is the best option, like the image on the left of the slide. This facility most likely would be set up once the crew has landed on the surface of Mars and must be able to constantly replicate Earth-like atmospheric conditions inside so that astronauts don't have to spend all their time in spacesuits. As Obata talked about earlier, long-term habitats might be better off underground, but human presence on Mars would have to be established before such a habitat can be built. These conditions for long human spaceflight, safe landing, and livable conditions on the surface of Mars are the main factors of any potential mission to Mars that we'll have to figure out far in advance. The safety and well-being of astronauts is a priority of any manned mission, and this would be a special focus with a mission to Mars, as it would be the first mission of its kind. As of 2020, the longest period of time any astronaut has spent in space is 438 consecutive days, which is just under 15 months and was within Earth orbit. Any Mars mission is likely to be much longer than 15 months, and we don't have a full understanding of how spending so much time in deeper space affects the human body. One of the main risks is radiation. On Earth, the magnetic field and atmosphere protect us from most of the sun's harmful radiation, which can increase cancer risk. In space, astronauts are exposed to much higher levels of radiation, and spacecraft must be shielded to prevent its harmful effects. Another risk is a lack of gravity. Body systems are designed to function on Earth's gravity, but spending extended periods of time in zero-G and on Mars means that a body would have to readjust to Earth gravity upon return, which can be difficult. A lot more research would have to be done about the effects of extended spaceflight on human health before we send a crew to Mars. As I mentioned earlier, food and water must be available without shortage for the entire duration of the mission. Food, which can be freeze-dried and stored in relatively small volumes, is not as big of a challenge as water. Water isn't readily available environmentally in space, but it may be on Mars, where astronauts and other researchers are looking to make it using Mars materials. And they're also looking at water reclaim systems, which have to be very efficient to supply each astronaut with at least 2 liters of clean drinking water per day, not to mention water used for other purposes. In addition to the effects of spaceflight and its associated risks on an astronaut's physical health, a long space mission can be detrimental to an astronaut's mental health too. I'm sure we can all relate to the struggles of socially isolating right now, but a space mission takes us to the next level. Astronauts would be confined to a small space with extremely limited communication to people back on Earth, and it's absolutely necessary to make sure astronauts have the space, physical activity, and living accommodations to be happy and healthy. Lastly, it's necessary to be mindful about how our actions can be detrimental to other environments. During shorter missions, waste can be compacted and stored until the mission returns to Earth, where it's properly disposed of. But during longer missions, it's more difficult to store larger amounts of trash, and a lot more space would be needed on board a craft. NASA is currently talking to American companies and looking for more efficient trash compacting methods that could be used for potential long-term missions. One potential candidate is a heat melt compactor shown on the lower left of the slide. However, there are still risks of interplanetary contamination. Forward contamination is the contamination of other celestial bodies by Earth life or materials, and back contamination is the contamination of Earth by potential life or materials from other celestial bodies. Both types of contamination must be considered when planning all our missions. While we have yet to confirm any life on other planets, lots of microorganisms on Earth live in extreme environments similar to those found on other planets, including anoxic conditions, which are conditions without any oxygen. Tardigrades, shown on the top right, are an almost indestructible class of microorganisms that can even survive periods of time in outer space. Accidental forward contamination of species like these to similar environments on other celestial bodies could result in the species becoming invasive. Even though there are lots of obstacles that researchers need to overcome before a manned mission to Mars is ready to launch, there have been significant improvements in space exploration technology in the recent years, and NASA projects a manned mission to Mars ready in the 2030s. This concludes our show for tonight. Thank you so much for joining us this evening. You have been listening to the Alan I. Carswell Observatory's weekly TeleTube broadcast, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Sana, Noah, Obata, and myself, Guggen. Make sure to leave any questions or comments in the comment section of the video below. You can always connect with us on Twitter and Instagram with the handle at York Observatory, and check out our website for show notes, content, updates, and contact information at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.
Thanks everyone for tuning in. Wonderful show, crew. And just a reminder to any folks in our live audience, we will be taking questions in chat live for about the next 20 minutes or so. And if you are watching this on recording and it hasn't yet gotten to August 19th or 26th, make sure to tune in on August 19th and 26th for special broadcasts. We are doing a 1-year celebration of our 1-meter telescope and a really wonderful astronomy Jeopardy game. For more, please see our website at observatory.info.yorku.ca. And in the meantime, we will see you over in the chat area.